Hi, this is Mr. Will from Uptuition with Mr. Will. Today we will learn about factorization of quadratic expression. Skill that probably gonna be used a lot when you're studying basic algebra. Typically, we have quadratic expression in general form, ax squared plus bx plus c. A is the coefficient of x squared term, b is the coefficient of x term, and c is the constant. So the first thing is, can we find common factors of A, B, and C? Let's use an example. 2x squared plus 8x plus 8. You can look here, the coefficient of x squared is actually 2, coefficient of x is 8, and the constant is 8. If you look at all this coefficient and constant, we can actually find the greatest common factor of 2. So let's factorize that out. We can also have another example. 2x squared minus 8. There's no x term here. There's no b. We only have the x squared term and the constant, right? We can simply factorize the common factors here, which is 2 and 8. So let's take out 2. We have x squared minus 4. Let's use another example. 3x squared plus 15x plus 18. We can factorize the 3, 15, and 18. This coefficient and constant. Let's take out the 3. Then we have x squared plus 5x plus 6. So let's continue. The next step is, can we use any of these 3 basic fundamentals formula in algebra? The square of sum, the square of difference, or the difference square. Expand this into a squared plus 2ab plus b squared. This one expand into a squared minus 2ab plus b squared. So the only difference here, you can see, if it is positive, this is also positive. If this is negative, this is also negative. But the remaining terms are basically have the same sign. And then the difference in square, that's just a plus b multiply with the difference. Let's see if we have any of this. So let's check it again from our first example. When we have 2x squared plus 8x plus 8. I can factorize that, as I have shown before, into x squared plus 4x plus 4. Now, we can look into these 3 forms and see we have 3 terms here, x squared, 4x, and 4. We should just check into these 2 forms, because the last form is just we have only 2 terms, a square of something minus with another square. Let's just check into these 2 forms. Write this in terms of a square of something, which is x squared. Can we write this into a square of something, which is 2 squared? And then we're going to use the middle term to check whether the middle term is actually twice of the first and the second term. Twice of the first term, x, multiply with the second term, 2. If you look at this, 2 times x times 2 is actually 4x. They are actually the same. In this case, I know that I can use the first form. I can just factorize it into a plus b squared. Basically, it's a perfect square form. This is just 2 times x plus 2 squared. So that's the fully factorized form. Let's try the second example. The second example, 2x squared minus 8, which we have factorized the 2 outside, x squared minus 4. If you look at these 2 terms, we just want to find whether we can look into this formula, because we only have 2 terms. It must be the difference in square. Can we make this into a square? So it's just x. And can we just make this into a square, which is just 2? And it's actually a difference, right? The difference in square. So once you see this pattern, you can quickly factorize this into x plus 2 and x minus 2. Let's look at the other example. 3x squared plus 15x plus 18. 3x squared plus 15x plus 18. Again, we have factorized all the coefficients and the constant. So that's going to give us x squared plus 5x plus 6. If you look at these 3 terms, you try to fit into either one of these, you cannot actually get a perfect square out of this. So it must be twice of the first term and the second term, And then the last term is not a perfect square number. So let's proceed with the next step. Once you try, your factorized form cannot be factorized either any three of this. We're going to use what we call as a sum and product method. When we have this 3x squared plus 15x plus 18, and then you have factorized the 3. So what you want to do is basically you want to look at the coefficient of your x and the constant term. You want to find two numbers. If you add up, it's going to be the coefficient of my x term, which is 5. But then if you multiply that two numbers, the result has to be the constant term, which is 6. So let me repeat that. The result of any two numbers has to be the coefficient of my x, which is 5. And the product of any two number has to be the constant term, which is 6. You can quickly find that number. It's just 2 and 3. That's the number I'm going to write here. X plus 2 and x plus 3. The first term in this case, because my coefficient of x squared is just 1, you can only get x and x, right? If you multiply x and x, you get x squared. Let's move on. What if we have another example? 3x squared minus 5x minus 2. What would you like to find is whether we have common terms here. So we have 3, we have -5, and -2. So we don't have any common terms. Can we look at any of these three fundamental formula that we can factorize? Doesn't look like so, because we cannot find a perfect square form of this, we cannot find perfect square form of this, and these are actually three terms. So we might want to use the sum and product method in this case. This is a bit different because if you look from above, the coefficient of x squared is still 1. You can just use this method where the sum of two numbers is the coefficient of x, which is 5, and the product is just this constant term 6. But in this case, now we have coefficient of x squared that is not equal to 1, like in the previous case. We would like to find the factor of that coefficient of x squared. So factor of 3, we can just use 1 and 3. Set up our factorized form. It's just 1 and 3. So I'm just going to write x and 3x, which actually 1 and 3. So after we do that, then we just have to find the factors of this constant. Factor of this constant. So we would like to use two numbers, -2 times 1 or 1 times -2. We have two choices here. Can do a little bit of trial and error. Let's say if I want to use -2 and 1, I'll just put it here, -2 and 1. I can actually check this result. Let me just multiply the inner part. -2 times 3x, then I get -6x. And then I can just multiply the outer part. That's just x. If you add these two together, -6 plus x, then I get -5x, which actually gonna be the same as this middle term. This is actually what we want to find. We don't have to check on the other possibilities. In the case I don't get -5x here, which is not the same as this, then I need to, keep plugging in any of these two combinations, find the multiplication of the inner product, multiplication of the outer product, and then take the sum of it, whether it's the same as the middle term. We can just factorize this into x minus 2 and 3x plus 1. Remember, take notice, if the coefficient of my x squared is not 1, then you need to do it a bit differently. The next step is, what if we cannot get the sum and product method? There's no other way. You can use the general formula. Simply just plug in ax squared plus bx plus c. Then we want to make it in terms of x minus x1, x minus x2, the factorized form. So that value of x1 and 2 is going to be -b plus minus square root of b squared minus 4ac over 2a. All this value b, a, and c is just coefficient of x squared, a, coefficient of x, b, and the constant term c. Okay, so that's about it. I hope everyone can understand this topic. Cheers!